Okay, this is the second video of the series, sketching transformations given the graph of the original function. In this video, we graph the following intermediate level examples. Example 1, 2f of x. There's only one transformation. The 2 multiplied outside means there is a vertical stretch by a factor of 2. Here is the given graph. This is f. And I will show you how to transform each point one by one. Starting with this point, we can see that it is 2 units away from the x-axis. It is that vertical distance from the x-axis that gets stretched. So instead of a distance of 2, it becomes a distance of 4. That's it. This used to be 2. A distance of 2 also becomes a distance of 4. And this distance of 2 becomes a distance of 4. You get it? Okay. Yeah. So, okay, I think we need some more points. This had a distance of 1. And it will now have a distance of 2, right? This, where's the distance of 1? This has a distance of 1. So it will now have a distance of 2, okay? That's it. 2. 1/2 f of x minus 3. So this 1/2 is a vertical shrink, okay, or compression by a factor of 1/2. And the minus 3 means that there is a horizontal shift right 3 units. So just work with the same graph, and let's do it point by point. This point had a distance of 2 units from the x-axis. You wanna have that distance. So it now just has a distance of 1. This also is 2 units above the x-axis. Have the distance. Okay, I'm not sure if I'm saying have the vertical distance. So 2 becomes 1. 2 also becomes 1. Okay. This used to have a distance of 1, so it'll be a distance of, that little distance is 1/2. And same here. Okay, and I think we have enough points. Oh, I forgot to shift the points to the right. Okay, so I'll just do it quickly. 2 units becomes 1 unit, and then move 1, 2, 3. 2 units becomes 1 unit. 1, 2, 3. Okay, this point is no longer there. This, have it, so it becomes 1, and then 1, 2, 3. Okay, and this point, have the distance and move 1, 2, 3. This point, have the distance 1, 2, 3. There. Okay, sorry, it's a bit messy. 3. F of 3x. Now the 3 is multiplied inside, so that is a horizontal transformation. Now you might think it is a stretch. It is not. It is a shrink. I told you in the first video, horizontal transformations are counterintuitive. Okay, times 3 is actually a shrink by a factor of 1/3. Let's use this graph. It's 1, 2, 3, 4, 5, 6, 7 points. Let's start with this one. So this is 1, 2, 3, 4, 5. It's 6 units away from the y-axis. That's the horizontal distance. You want to shrink that by 1/3. So obviously 1/3 of 6 is 2. So it's here. This point moves closer. It shrinks. It moves. It's the distance. Okay, it's not the point, rather. The distance shrinks. Okay, how about this one? This is 5 away, and 5 divided by 3 is 1 2/3, so about 1.7, so somewhere here. It shrinks. This one, 4 divided by 3 is about 1.3, so a distance of 4 now becomes a distance of 1.3. This distance of 3 becomes a distance of 1. This distance of 2 becomes about 0.7. Okay? The distance of 1, obviously 1/3, somewhere here. A distance of 1 becomes a distance of 1/3, so it's somewhere here. And a distance of 0 is still 0, so it's there. That's... so hard to graph. There. It there's a horizontal compression. It just horizontal squishing by a factor of 1/3. Example 4, 2f of 1/3 x. So I think you should know by now, the outsides are vertical and the insides are horizontal. This is a stretch times 2, and this is also a stretch. 1/3, the reciprocal of 1/3 is 3, so it's a stretch of times 3. Let's use this graph. Okay, let's use this point, this point, this point, this point. Okay, a vertical stretch by a factor of 2. Oh my goodness, 9 becomes 18. Okay, I changed my mind. I'm just going to use, I'll just use these 3 points. Okay, so this one, it doesn't have any vertical distance from the x-axis. So a 0 distance, even if you double that, is still 0. So the vertical stretch does nothing to this point. And then a horizontal stretch, that one we can do, because right now it's 2 units away from the y-axis. That's its horizontal distance. 2 times 3 is 6. So this is where this point goes. This point had a vertical distance of 1. You want to double that, so 2. And then its horizontal distance was 1. You want to triple that. So again, this point goes higher and expands farther right. And we can already connect that. And then this point, again, a vertical stretch does nothing. 0 distance times 2 is still 0. And the horizontal stretch, it has 0 distance from, it has a 0 horizontal distance from the y-axis. So 0 times 3 is still 0. So that's where it stays. And we can connect it. This point will go somewhere here, okay? Because this used to be at 9, now it's going to be at 18. And it used to be 3 units away, so if you want to triple the 3, it'll be here at 918, if that makes sense. This is the graph, stretched vertically and stretched horizontally. It became a giant. Okay. The last example, example 5, -2 f of -x minus 3. This one has 4 transformations. So there is a reflection over the y-axis. No, the x-axis. Okay. It's a vertical reflection. Okay, anything outside the parentheses is vertical. So this is also a vertical transformation, and this is also a vertical transformation. This one in here is a horizontal transformation. So 2 means there's a vertical stretch by a factor of 2, and this means there's a vertical shift down 3 units, and the horizontal transformation is a reflection over the y-axis, which we've demonstrated reflections and shifts in the first video. So, yeah, again, just do it point by point. Ready? Okay. I'll first do the reflection. By the way, we need to do reflections and dilations before any shifts or translations, okay? So, what used to be 2 units below will be 2 units above, okay? That's the reflection over the x-axis. Now for the vertical stretch, 2 units vertical distance becomes 4 units vertical distance. We're not done with the reflections and dilations. There's one more, a reflection over the y-axis. So it used to be 2 units to the left. It should reflect over here, 2 units to the right. And then we shift down 3 units. 1, 2, 3. This point ends up way over there, okay? And then for this one, reflect over the x-axis. Stretch it by 2. Reflect it over the y-axis. Shift it down 1, 2, 3 units. This next point, reflect it over the x-axis. Stretch it by 2. Reflect it over the y-axis, it stays there. And then shift it down 3 units, 1, 2, 3. And we can start connecting. As long as you're doing the points left to right or right to left, as long as you're transforming them in an organized manner, you can start connecting them. So we're done with these 3 points. This last point reflects over the x-axis. So it used to be, it's 8 units above, no, it's 7. What am I saying? 3, it's 7 units above. Reflecting over the x-axis will be 7 units below. And then there's a vertical stretch. The 7 vertical distance becomes 14. Then reflect it over the y-axis. Its horizontal distance is still 1, so it just reflects 1 unit. 1 unit from here, it reflects there. And lastly, shift it down 3 units. 1, I'm just eyeballing it, 2, 3. That's where it is. And how do we connect that to the graph? It's, why did I even? There. Okay. It reflected over the x-axis. It got stretched vertically. It got flipped horizontally as well. And then it got shifted down 3 units. So these are the intermediate level examples. There's still a 3rd video for advanced level.